Hello and welcome to our domain and range video, our second video um, of Unit 2. All right, I'm back. We are back. I'm excited. Domain and range is a big, nice little topic for us. It's pretty cool. So yeah, let's see it. So what are our learning targets for today? So 2.2, all right, is going to come in two parts. Today we're going to discuss domain and range. In the next video, we'll discuss the zeros of a function. All right, so our learning targets of the day are to find the domain and range and write an interval notation, and to find the range from a graph as well. Okay, domain. What is a domain? Domain are your input values. It's your independent variable. It's your x values. Okay, it's everything that you put into your function. The range is what you get out. It's your output values. It's your dependent variable. It's your y values. It's whatever you get out of your function. Okay, domain and range. So domain, oh boy, and range can be written using interval notation. All right, so we talked about interval notation in our last unit. Okay, so that's going to continue, and we're continuing to build on that in this unit as well. So what does that look like? Okay, remember the interval notation can look like negative infinity to infinity, or -4 to 16. Remember that the bracket, the hard close, means it's inclusive, means your value can be equal to -4, and the parentheses is not inclusive. It cannot equal, whether that's your domain or range, cannot be 16. Okay, um, let's look at domain first graphically. So when thinking about domain, or when trying to look at a graph and decide what the domain of our graph is, I want to read my graph, or look at my graph from left to right, so from the lowest to the highest. Okay, so when looking at a graph like such as this one, I'm going to use this line here. Okay, I want to think about, all right, well, what are all my possible x values? If I start from the left, what's my graph doing? Well, I can see by this arrow that it's going off to infinity. So there's some really big, some really big negative number over here, and it's continuing and continuing. There's still x values, all the way up off to positive infinity. So no matter what number I input into my function, I'm always going to receive an output. So my domain of this function is all real numbers, or negative infinity to infinity. And you may see this symbol written as well. That's all real numbers. Okay. All right. So let's look at a cubic function. Now we're going to imagine that there are arrows here. There should be. Okay, there are arrows there. All right. As I move across my graph, remember, this is kind of like a vertical line test. I like having this here just as a visual to see myself moving from left to right. You can obviously use a pencil or something like that. You can use your finger too. Okay, I just like the visual component of it. Okay, so moving from left to right, where do I hit my graph first? Right here, right? Well, that graph is going down forever. It's going off to an insanely large negative number. So my first x value, my lowest possible x value, is negative infinity. As I continue on, my graph goes off to a very large x number, so it goes to infinity as well. That's also all real numbers. Okay. Our third example is when our graph starts to get a little tricky. All right, things start to get a little tricky here. Okay, because here, our graph, there isn't an arrow here, meaning that it just starts at that actual point. Here, you can imagine there being an arrow since there's not a hard close, just like there is here. Okay, so as I move from left to right, our graph does not have any outputs. There aren't any outputs over here. There aren't any y values over here. The first x value that I hit on my graph is here, is -1. Okay, and then I continue to go on to infinity. All right, so x, I'm going to write it in inequality notation. X is greater than equal to, that should be a -1, I apologize, -1. Well, in interval notation, what's that going to look like? That's going to look like -1 and any number bigger than -1, so off into infinity. It's going to be a soft close here and a bracket there. All right? So domain is from left to right. Okay, left to right. All right, when I think domain, I think left to right looking at a graph. Okay. Well, let's think about it algebraically. When thinking about it algebraically, I want to think about what x values do not work in my function. Okay, what x values do not work. Domain will include all the x values that do work in the function. Okay, anytime I input a number, I can get an output for that number. So if I think about my quadratic here, x squared minus 3, whatever number I put in, can I put in any number, whether that be a huge negative number or a huge positive number? If I input one of those two things, am I always, and then I subtract 3 from it, will I always get a number back? And the answer is yes. So here, again, our domain is negative infinity to infinity. All right. With the cubic, same thing. I can multiply a number by itself 3 times, no matter how big or small that number is, no matter how negative or if it's positive. So that's going to be negative infinity to infinity as well. Okay. Here's when things start to get tricky again. All right. So I have this square root function. Okay. I have this square root function here. All right. So what type of numbers can I not take the square root of? All right. I cannot take the square root of a negative number. Okay, so that means whatever is underneath my square root, here it's x plus 1, it must be positive. So x plus 1, well, if I want to say, I want to write a number as positive using inequality notation, x plus 1 must be greater than or equal to 0, because that would imply that it's always positive. Okay, well, let's solve for x here. Subtract 1 from both sides. X must be greater than or equal to negative 1. Well, how would we write that interval notation? Inclusive on negative 1 to infinity. Wow, that's neat. Okay, let's try another one here. All right, let's look at a fraction. Okay, within a fraction, I can divide by negative. I can divide by a fraction. I can divide by a positive. I can divide by a very large number. But there's one number that you cannot divide by. What is that number? It's 0. I cannot divide by 0. So my fraction, the denominator of my fraction, the bottom of my fraction, cannot equal 0. So x minus 5 cannot equal 0. Well, that tells me if I add 5 to both sides that x cannot equal 5. So if I want to write that in interval notation, well, x can be any negative number, so negative infinity to 5. Now, not including 5. All right, union, pick back up at 5. Oh boy, I'm going to write the rest of this down here. Okay, let's try that again. I'm going to go union 5 to infinity. All right, so I'm not including 5, but I'm picking back up at 5. So I'm going all the way from negative infinity to 5, boom, and picking back up. Okay, and we'll look at the graphical representation. We'll look at that in a little bit. All right, maybe on the next one. I don't know. We'll see. Here we go. The suspense is killer. So if I look at, now that we've done domain, algebraically and graphically, let's talk about the range, and we're going to go graphically first. Okay, so from when I'm dealing with the range or thinking about the range, I want to, think about our guy Drake. Drake says to start where? You start from the bottom. So when I'm talking about range, I read from the bottom to the top. All right, start from the bottom. Now we're here. Okay, so now if I start at the bottom, my graph, or excuse me, my line, it's here. Well, what is that point? What is that y value? It looks like it's 1, 2, 3, I believe. Is that negative 3? Yeah. And then it goes on. If I continue to move up, my on forever. All right, so my range is y must be greater than or equal to negative 3. In interval notation, that looks like negative 3 included to infinity. Okay. Range of number 2. What is it? Great question. Wow. So if I look at my range, again, you can imagine there being arrows here, and here there should be arrows there. All right. I go from the bottom. It starts at some very large negative number and goes off to a very large negative number. So my range is actually negative infinity to infinity. Okay. Here again is where things start to get tricky. Okay. I slide my pencil up or my line up. Boom. I hit a point. I hit an ordered pair. All right. My value of y there is what? It's positive 1, I believe, right? I mean, that's tough for me to see. Is that positive 1? Yeah, that's positive 1. Okay. So that's positive 1. Well, that tells me that y, and then my function again goes off forever. Although it's increasing slowly, it's still increasing off forever. So y must be greater than or equal to 1, or in interval notation, which we will use, it's going from 1 to infinity. I'm showing you the inequality notation because sometimes it's helpful to see that just to understand it, okay? But interval notation is best here. All right. Now this is that special case we were talking about in the last one, our last special case over here where our denominator cannot equal 0. All right. Well, here if you look at, remember it said x cannot equal 5. Well, at 5, there's this nice vertical asymptote here. Well, guess what? As I bring my line up, all right, it's starting at a very large negative number. Boom, there's this little break here. Okay, there's this break at 0, and then our graph picks back up again. Okay, so this is called a horizontal asymptote, right, which we'll deal with later. All right, but y cannot equal 0. So I'm going to skip 0. I'm going to go from negative infinity to 0, pick it back up, and then 0 to infinity. All right, so that would be the range of that last one. Okay, here we go. Remember, you can always rewind this and rewatch some part if I went pretty fast or you're getting kind of confused. All right, so first question on this one, is this a function? Remember to determine a function when you use the vertical line test. So here's my vertical line. Red meets blue only once everywhere. So yes, yes it is. All right. What is the domain of this function? Well, you see that we have two closed dots here on the beginning and the end. All right. So the domain of this function, if I think about it, remember domain we read left to right. So domain, the first x value I hit looks to be, is at negative 5? Yes. Negative 5. Still keep going. I'm still good. I'm still good. I'm still good. And I end at positive 5. So my domain is negative 5 to positive 5. My range now, okay, let's see if I can get this horizontal. That's techie. Sick. Okay. So I got this horizontal now, so I got this line. I'm going to start from the bottom. Start from the bottom. Boom. The first y value I hit is negative 3. The last y value I hit is positive 3. So I go from negative 3 to positive 3. Now there's no infinity because our graph just stops. It's bound by those points. All right. Let's try another one. Yes, of course. Why not? Here we go. Why don't you try this one on your own? Okay. Pause the video and then we'll pick back up in a minute here. All right, so this is a function, passes the vertical line test, even though there's this break right here, but that's a closed dot up here, closed dot down here, open dot up there. Domain, left to right, all right, negative infinity, negative 1, not inclusive, so there's an open dot. There's a break here. I pick it back up at 1. And it looks like there's a break, but there's a value at 3, and then I go all the way to 6. Same thing, range, negative infinity because of this arrow down here. All right, and there's always a y value, even at 2 here. There's always a y value, and I go back up to 6. All right, and that's an open dot there. Okay, so I don't include 6 on that. All right, so I have 1 minute to try to get through these 4. So the first 2. All right, I can input any y value, x value, and get a y value in a linear graph. Now you can look at any of these 4 using Desmos or using your graphing calculator and decide the domain and range that way. So my domain and range is negative infinity to infinity for this one, and for the cubic as well. Okay. So remember this one, denominator cannot equal 0, so x plus 2 cannot equal 0, so x cannot equal negative 2. All right, range, there's not a value here that's going to give me 0. All right, so I cannot include 0 on this one. The numerator here will not equal 0. We'll talk about that later. Remember, you cannot take the square root of a negative number, so anything inside the square root must be greater than 0. All right, and when I take the square root, I'm going to get a positive number, so my range must be greater than 0. All right, and that's domain and range.